My name's Kerry Anderson. I'm a fire research scientist at the Canadian Forest Service. Been there for many a year. My background is in meteorology, and I've been working with the fire group Northern Forestry Center in Edmonton for about 25 some odd years. This talk today is our prediction of what the fire season is going to look like in 2013. We've actually been doing this work since about 2006. At the invitation of the U.S. Forest Service, invited us down to try to produce a continental scale forecast. And since then, we've gotten more and more involved in this. So we've been doing these predictions here for a number of years now. So just as an introduction, the CFS is presenting monthly and seasonal forecast maps through the Canadian Wildland Fire Information System. The easiest way to find the CWFIS is just simply to Google it, or Bing it now, I shouldn't. This will present a lot of the information I'm showing here. Our forecasts are based on products from Environment Canada. They've been producing monthly and seasonal forecasts, and as well as advice and data from the provincial agencies. So this presentation is going to summarize the conditions in 2013. Again, this is being presented through the Canadian Wildland Fire Information System. This is a website that we've been running out of Edmonton for a number of years. And what we do is we actually collect all the weather information from across Canada, all the Environment Canada stations, provincial fire stations, and we plot maps of the fire danger across all of Canada and present this information on a daily basis. So these maps are updated every day. And there's about 1,800 weather stations that go into these calculations. Again, you can find the website, there's a link there, but the easiest way, as I said, was to just simply Google it, do a web search, and you'll find it really quickly, top one. Looks like my numbering scheme kind of went squirrely, but that's okay. So briefly in the methodology, the idea is we start with we consider the spring startup conditions, and that's based on what the conditions were like in the fall, as well as the amount of snowfall, the overwinter precipitation. We take that information and apply it to an average daily weather for a number of weather stations across Canada. Then we incorporate Environment Canada's seasonal predictions. And finally, we take the resulting information and feed it through the Canadian Fire Weather Index system to come up with estimates of what the severity rating will be. More graphically, just to recap what I just said, we take the fall conditions of the drought code, how dry it was in the fall. We calculate independently. We calculate a time series of the average daily weather at a weather station. We consider the seasonal predictions that Environment Canada are giving us, and we apply these to that average time series. And from that, we feed it into the Fire Weather Index system and come up with predictions of the fire weather anomaly, as we call it. So this is above average or below average. Naturally, this will capture some of the climatic conditions. So an above average fire season in Labrador might be a bit different than an average fire season in Kamloops. Right now, we're incorporating what we call ensemble models. This is really the kind of state of the art in terms of weather forecasting techniques. We take the Canadian Meteorological Center, CMC, out of Montreal, runs global models to predict what the weather is going to be like over the next as much as 12 months ahead. And they use these global models, these two ones, the CMC the CAN CM3 and the CAN CM4, which are generations 3 and 4 of a global atmospheric circulation model. And they use that to predict the conditions in Canada. The benefit of using an ensemble approach is, imagine it's sort of like having 10 weather forecasters in the same room, creating their own forecasts, and then have a vote as to which is the best. So what we're seeing here on this diagram here is predictions of temperature and of precipitation. And each one of these purple lines is one of those predictions. The nice thing about ensemble approaches is you can also get an assessment of how confident the models are in their forecast. So as we see the various time series of these weather forecasts, when they start to spread, that means that the models aren't agreeing with each other. Well, on the other hand, when the models are quite tight, the forecasts are quite tight, then we get a measure of the confidence that these models are agreeing with each other. So that's the benefit of this approach. So it's worthwhile at this stage to just recap the forecast for 2012, what we did. 2012, as it turned out, was a relatively normal fire season. We just had slightly below average, 7,288 fires, just 100 or so below average. And the average area burnt was slightly above average, 10% above average. As it turned out, most of the fire activity happened in Labrador in June, where we saw some large fires there, which was really quite unusual for Labrador to see these numbers of fires, as well as a band from northern B.C. all the way down through into Ontario and Manitoba. This band was primarily in the north, as much of the prairies actually saw relatively cool summer weather that year. Now, based on the data that CMC gave me last April, these were the forecasts that we put out. As it turned out, I could say with some degree of confidence that we did quite well for a number of fires that were happening in the Yukon in June. We didn't do too well picking out that fire activity in Labrador, unfortunately. We did do fairly well at predicting the fire activity that was happening through Alberta, as well as that area of Ontario and Manitoba, which you see kind of repeating itself in September. One thing that we didn't do well on was picking out that cool summer weather that we experienced in the prairies last summer. If it wasn't for that, we probably would have had a more extreme fire season. Naturally, these are seasonal forecasts. These are these are 2, 3, 4 months in advance. The science isn't perfect, but I'd like to think that we're doing better than we're not doing. That's the way I always like to phrase it. So in summary, for 2012, the forecast fared quite well, we thought, for northern Canada. And most of the fire activity, except for perhaps what happened in Labrador, we actually picked up within this system. One thing we noticed, and it didn't, you saw these forecasts with these dark red areas. Unfortunately, we didn't do as well of a job at calibrating thresholds of above average and extreme. We kind of missed out on that, and that probably was a bit of a red herring. But we have kind of reassessed those thresholds of above average and extreme conditions, and that's what we're going to be applying in this coming season. So let's go through the starting conditions.
Matthew,
yes, absolutely.
So what happened in Labrador? What was different in Labrador this year that you didn't think of prior? Was it a lightning strike or was it?
No, it was just a large fire that primarily kind of dominated a lot of the activity in Labrador. I'm a little bit, I probably should have investigated that more closely, I forgot. But certainly conditions in Labrador, what's quite unusual about the Maritimes is the salty weather will actually end up drawing the fuels a lot more than we account for within the fire weather index system. And sometimes we'll see extreme fire weather conditions, a lot in like Nova Scotia and whatnot, happening in conditions that in the rest of Canada don't show up as being very extreme. Mike Watten's kind of anyway. That's a tangent there that we could perhaps discuss later. But for now, we'll just keep on going on. But certainly, if anyone in the group here has any questions, by all means, feel free to interject here. So starting conditions. We start off with looking at the conditions in the fall. And for that, what we look at is what we call the drought code. This is one of the components within the fire weather index. It's very similar to the 1,000-hour moisture code for any Americans that might be out there. They'll be presenting this forecast to Americans later. And all the other moisture codes within the fire weather index are reset. Yeah, that was the slide I was expecting. So again, where we started with in the fall was some very high values of the drought code, as you can see in that very deep red, extending all the way from the Yukon down into southern Manitoba. So Western Canada had a very dry conditions, very indicative of the forecast that we did produce. So I mean, this somewhat supports our forecast for last year. We just didn't have the spark for the fire. But as it turned out, in October we had an early snowfall throughout much of the prairies, so we ended up with a lot of snow. If we look at the drought monitor conditions, we actually see that Canada, as of this was produced in late February, is for the most part a relatively normal pattern across Canada. Most of the drought that's being experienced is in the U.S. Midwest, but this is not extending into Canada. Most of the snowfall has reset that back to normal conditions. If we look at the current conditions of the snowfall, and that's dated as of yesterday, we actually see that much of Canada is still under snow. Indeed, the snow area extends all the way down into Colorado and even touches into New Mexico and Arizona. So this is very unusual. And with the snow cover, you don't need to be a fire weather forecaster to realize that we're probably going to be experiencing a late fire season, start to the fire season. If we look at the amount of snowfall that's happened, we see that the snow amounts range from about 60% in some areas of eastern Canada. But when we move into the prairies, we're looking at values that are 100, 150, 200% of the normal amount. So again, we're looking at this amount of snow we've received this winter as resetting most of the drought conditions, except for perhaps these areas in northern Saskatchewan and northern Manitoba, which we'll probably touch on later. In terms of the startup this year, well, there's not too much to say. Because of the amount of snow cover in Canada, we have not started the fire weather index system yet, except for occasional spots in the interior of B.Sc and southern Alberta. And these areas, well, they're showing high, but that's quite typical of southern B.C. Now we want to maybe just quickly touch on the ENSO pattern, or the El Niño Southern Oscillation. Just for a bit of background, this is that band of warm weather, or warm water that goes around the tropics, around the equator, extending from Indonesia all the way to South America. Extremes in this oscillation can lead to extreme conditions in other locations in the globe. ENSO tends to kick in usually tends to develop in April and June and tends to reach the maximum in winter. These patterns typically persist for about 9 to 12 months and recur every 2 to 7 years. Why am I talking about ENSO when we're thousands of miles away? Well, as it turns out, ENSO, the El Niño effect, does have effects in Canada, and these can lead to above precipitation amounts in southern Alberta and Saskatchewan, but can also lead to above average temperature conditions throughout much of the prairies as well as southern Ontario and Nova Scotia. So then we move into this rather interesting diagram for the El Niño pattern. The Institute for Research, or the International Research Institute out of New York City, out of Columbia, as well as the Climate Prediction Center as part of the National Weather Service in the U.S. They keep track of all the global circulation models that are going on. And there's as you can see on the right-hand side, there's about 24 of these that are being run from Japan, from France, from all around the world. And often what we'll do is they'll plot the predictions of all these various models to see what the prediction for the next 12 months will be. As it turns out, the center bar here is the 0, suggesting that there's going to be a neutral condition. And many of the models are predicting this neutral condition. But as it turns out, the Canadian model is actually predicting high values of these sea surface temperatures. And this is going to, again, carry through into this forecast for the summer for Canada. We can also kind of do a histogram having an election, so to speak, saying that most of the models are predicting neutral conditions for the ENSO. But and keeping in mind that Canada is actually on the high side, it's probably one of those red bars there. But as time develops, the models kind of come into kind of a neutral condition where they don't quite agree with each other, where they're getting an equal election in all the conditions as the models tend to spread. So this leads into the Canadian the seasonal forecast that's been produced by the Canadian Meteorological Centre. These are these red, white, and blue maps that many of you have probably seen. This is the forecast that they've produced for April, and this was produced on March 31st. It doesn't quite capture a lot of the events of the last couple of weeks, it seems, with the snowfall. But we are looking at what appears to be above average temperatures in southern B.C. and southern Alberta, as well as above average temperatures along the Atlantic coast. In terms of precipitation, these blue areas indicate below average precipitation. The two graphs on the bottom is an indication of the confidence of the forecast. And the models seem to be quite good agreement for the forecast for temperature, although they're a bit shaky in this above average area for southern B.C. and Alberta, which maybe reflects this unpredictable spring that we've been having. And precipitation, they've always had a bit of trouble with forecasting precipitation. That's more difficult to predict. But some of the areas here that are below average are showing up with the highest confidence. So that's a bit of a red flag. Now this is for a 3-month period from April, May, and June. So this doesn't necessarily capture what's happening out there right now, but what's going to happen in the in the spring here. Now as we move into the early summer, we start to see the temperatures being predicted, especially for Western Canada and Western Ontario, as being above average, as well as Atlantic Canada. Confidence starts to wane as we get into these longer range forecasts. Also, we're seeing this band of below average precipitation through the Manitoba, Western Ontario, up through into southern NWT. We're looking at below average conditions in B.C. as well, and above average precipitation on the Atlantic coast, kind of canceling out the above average temperatures. If we move on into the late summer, July, August, September, we're seeing practically all of Canada, except for eastern Quebec, and western Quebec and eastern Ontario, as showing above average temperatures. Precipitation, again, this band of below average precipitation extending through northern Manitoba, northern Saskatchewan, northern Ontario, is showing through, as well as below average precipitation in B.C., southwestern B.C. So this leads us into the actual forecast that we're doing for the fire weather conditions. So all those factors are being brought together into this prediction. So what we're seeing here, again, on the left-hand side is our prediction of above average or below average fire weather conditions. Now, this doesn't necessarily reflect the climatology and how likely fires are going to occur, because, as I was mentioning before, I don't mean to pick on Labrador, but fire weather conditions, an average fire season in Labrador is a lot different than an average fire season in Kamloops. And so what we're seeing there is, through the colors, are our forecasts above this average value. What you're seeing in the hash marks here are the actual forecasts of the fire danger. So you can see, it's a little bit faint, but you're seeing practically all of Canada showing up as low fire hazard. Well, on the other hand, this pink area is showing above average conditions in southern BC. That's about the only thing that's showing up on this map. On the right-hand side, we've got the confidence. Now, if you remember that the ensemble approach, we're actually producing 20 forecasts, and we're calculating the median of this forecast, but we're also calculating the standard deviation of those predictions. And what it's showing us here again is that the confidence is relatively low in this southern area. So we're actually, as it says, we're seeing high confidence in all but southern BC and Alberta. Perhaps again reflecting this shaky start to the fire season, or shaking conditions we've been going through right now. As we move into May, though, we're starting to see the fire danger rising up, especially in British Columbia and some of the southern prairie areas. But most of those areas are not forested, except for the foothills in southern Alberta. Again, the confidence here is not as high as the confidence is throughout eastern Canada. As we move into June, we're starting to see those above average temperatures kicking in. And we're seeing most of Western Canada and Western Ontario showing up as above average fires, as above average fire severity, possibly this summer. Confidence is moderate, except for the southern Manitoba area and southwestern BC. Into July, we're continuing to see this above average conditions in Western Canada and moderate conditions, or moderate confidence in this forecast. Finally, as we move into August, well, not finally, but as we move into August, we're starting to see the conditions in British Columbia begin to wane, except for the southwest. Much of the prairie provinces and Northwest Territories and northern Yukon and Western Ontario as well continues to be above average, although the confidence in this forecast is starting to drop in the prairies in Alberta. Finally, as we move into September, we start to see, as fall takes hold, we're starting to see this hashed line of kind of gray area showing up through much of Canada as the conditions, as the severity, the raw severity values actually drop. In terms of above average conditions, we'll continue to see southern B.C. showing up as above average for that time of year, as well as the southern prairies. So in summary, it appears that Canada will see a late start to the fire season. I mean, no surprises there. As summer develops, though, the fire weather conditions, especially that in Western Canada, will likely rise to above average. The well below normal snowfall in northern Saskatchewan and Manitoba, as well as those bands of below average precipitation, may actually promote some extreme fire activity in these areas in northern Saskatchewan and Manitoba. And as September comes to an end, we might see an early end of the fire season this year, except perhaps in southern BC. And that's essentially it for the presentation. One thing I perhaps want to mention here, if we go back, I apologize, I could have mentioned this earlier. This is a pattern that we're practically seeing year after year in these forecasts by Montreal, where these temperatures are showing up as above average. Year after year we're seeing this. I should perhaps explain that these values are based on a 30-year average. And you just have to listen to the news to hear the reports of how each summer seems to be showing up as a record-breaking summer for temperatures in Canada. And that's being reflected, I think, in these maps. So again, they're forecasting another above average temperatures in Canada, and especially if we look at this band here throughout Manitoba and northern Saskatchewan, it could be interesting in the far north. So that brings us to an end here. And any questions around the table here at this stage? Yes.
Can you go to the drought conditions slide? The one current level of drought conditions.
Okay,
There's one with a little blue. Everybody's clean except
this one you're talking about from the North American drought. Is that what you're talking about? This guy?
Maybe.
Around Regina?
Yeah. What happened? Why is there a big blue dot there?
Oh gosh, a lot of snow, I guess. I can't tell you specifically. I'm sorry. But certainly what you're seeing here is through the prairies. We've had an unusually high amount of snow.
So I meant the one where the drought conditions. So it was bad. Not the starting point.
Okay, let's walk through these quickly here, and you can tell me what
the next one.
About. This one?
No. North
America? Okay, this is the drought code conditions in the fall.
You had, in southern Alberta, there was one spot right near the border that was much drier than everywhere else.
Okay, are you talking about this area, this one?
No, that's, Saskatchewan got hit with lots of snow.
Yeah.
I misinterpreted the graph.
What about the fire weather map, like the existing one from April 11th?
Yeah.
Okay.
What's that one dot? Why is that one so much?
Okay, well, in order to start the fire weather conditions, we need 3 snow-free days, and it has to be above 10 degrees at one time. What you're seeing there is probably like the Lethbridge area, and well, I haven't been down to Lethbridge lately, but it's often very windy, very dry. They may have missed the snow that much of the other areas have experienced. If we go back to this map, we can actually see from the current snow cover that indeed that little spot of Lethbridge, Medicine Hat, into the southwest corner of Saskatchewan managed to avoid the snow that much of the prairies have experienced. And indeed, this is probably what we're experiencing in Toronto today. Does that answer the question you were asking?
Yeah, well, I just, is there a microclimate around Lethbridge, or?
Well,
I've never seen that.
I apologize to the people remotely trying to keep track of my sliding around here. This was the graph I was looking for. So what we're seeing here is, again, this little band around Lethbridge, Medicine Hat. The thing to keep in mind here is that, I mean, this is notorious for its wind and erratic weather. If you talk about Pincher Creek, you can get Chinooks coming through there and 6 feet of snow one day, and the next day it's all gone because of these radically changing weather conditions. It's not unusual to have dry, I mean, well, what is unusual is snow this time of year. But these guys managed to avoid it, is what this map is saying. Is one small little corner managed to avoid it.
And it probably overwintered at a really high value.
Yeah, if you look at the...
I mean, that the striking part of it is that they've started the calculations at this point, but it probably, I think Kerry's map of what it, the October 15th map there showed everything was really extreme there.
So you can see the drought conditions in the fall were already very high. Extreme. Drought codes of over 400, which probably isn't too unusual that time of year for southern Alberta and southern B.C. But as you can, I apologize for going back and forth a lot for those that are trying to follow this on the WebEx. But this little band of yellow precipitation is indicating actually it's below average precipitation in that small little corridor. And then what other map did I want to look at? The drought conditions. If you look here, you can actually see little spots of yellow showing through there. So all these various independent systems are, in a sense, catching that this yellow area is saying abnormally dry. So that area of southern Alberta is showing up as quite dry, and it didn't get the snowfall, and it didn't get, and it's probably above average conditions right now. Okay. Yes.
Kerry, the daily fire hazard maps.
Yes.
We know the maps are archived. You can go way back.
Oh yeah.
Look, but is data behind the maps also archived, and is it easily accessible?
With the Canadian Wildland Fire Information System, it's more than just a web page, as my colleagues keep reminding me, and that it's a whole framework, collection of databases that we've been collecting and building over the course of the last 10 or more years. So we actually have the historical weather conditions that go back often to the 50s and 60s. So we've amassed all this data, as well as the fire databases, the large fire databases, the small fire database, which kind of creates the national fire database. So we have all this information that's in behind the system. Yes, it takes some time for us to actually plot all these maps. Most of these maps are archived, but the data behind it is collected and stored in Edmonton.
Is it accessible? Is there a price tag on it? Can a private entity get their hands on it?
That's a good question. I would have to follow up on that. The reason why I say that is a lot of this data doesn't necessarily belong to us. It actually belongs to provincial agencies as well as Environment Canada. And sharing that data sometimes, we've involves provincial agreements with the provinces. Some data may be accessible, some data may not be. And but you're welcome to contact me, and I can put you through to our people that are managing that database. We can follow up on that. And certainly anyone on the WebEx conference line is welcome to contact me at any time with any of these questions. Look forward to phone calls and explaining why Lethbridge is showing up as above average. Not picking on you, I'm just kidding. Any other questions? Yes.
I found it interesting, going back over your presentation for my mind, and you're saying, well, we've got a late start to the fire season.
Yes.
And then you say we're going to have an early end to the fire season.
That's,
and then
could be a short summer.
That's I guess what I took out of that is you're forecasting a short summer, and even though it's a short summer, you're forecasting above higher temperatures.
Let me just see what the.
I think that's what I heard you say. And then you also expressed some dissatisfaction in using a 30-year average to describe our current climate conditions because they're changing faster than the 30-year average allows us to appreciate, if I'm not putting words in your mouth.
No, that's fair enough. I may have been kind of stepping out a bit far, saying it might be an early end of the fire season. I was looking at the way the system was predicting the low fire severity. It doesn't necessarily mean that it's going to snow on September 1st, hardly. But it could. I'm just following. When we put all these numbers through, we end up with this band. We end up with this band of low forecasted severity that throughout most of Quebec, except for the central spot for some odd reason, and following kind of the northern prairies in northern B.C. Is that abnormal? Well, it's not except for this area in Ontario or northern Manitoba, it's at least showing up as average. Does that mean that, I guess we've got, sorry, I apologize, we've got the Yukon and Northwest Territories also showing up as above average. But usually the fire season in some of these areas end kind of mid-August.
Do you have any slides which actually show us what the average fire hazard is? Like all your graphs that you showed us are just tendencies based on the average, I understand. But
well, in a sense, that's what this gray hashed out area is it's showing the areas that is the forecasted as low fire danger as opposed to above average or below average. It's showing you the raw actual forecast. If you go to the website, I've only shown in this presentation these two graphs of the anomaly and of the confidence, but in the on the website we actually have the forecasted values. But it's a valid point that you're bringing up, and maybe I'll take a closer look. I am kind of going out on a limb saying it might be an early end of the fire season, but that's also 6 months away. Conditions could change quite quickly.
I guess kind of related to the early or late start to the season, early end. So one of the things you often read about for climate change is that we'll have a longer fire season. The longer fire season gives more opportunity for fires to occur. And this season we still have snow in April, so it's a late start and then maybe an early end or whatever. But would you say over the whole season that we'll see more? Like I guess you had your maps for June is going to be above average in some areas in July, and then over the season it's going to be above average. But the season's going to be shorter. So does that mean we'll see more or less?
I'm probably going a bit outside of my realm here to talk about this stuff, but perhaps it might answer some of your questions. The concept of climate change, and everybody talks about the temperature going up and and precipitation going up or down. I'm not too sure. What's physically happening is as the globe is warming, we're getting more mixing going on. So that temperature gradient between the equator and the pole is creating a lot more fluctuations, hence a lot more weather, a lot more extreme weather, whether above average temperatures or snowfalls in April. I think what we're seeing is this more radical changes from one condition to another. Much like if you imagine putting a pot of water on a burner on the stove, the water, when it starts to approach the boiling point, you can see all those convective currents. As the cool water at the top is mixing with the hot water on the bottom, you're starting to see more and more rotation. And I think that's what's happening with some of these forecasts. Well, I mean, that's what I believe is happening in climate change when the meteorologists talk about more extreme weather. And that's why we end up with things like Snowmageddon, and next thing you know, we've got the hottest summer on record, and we're seeing snowfalls in Arizona and conditions melting in Alaska. You know, that's I think what we're experiencing. And I know that there's some people that are kind of skeptical about climate change. I'm not trying to get into this debate or anything like that, but
I guess my question is also about climate change and about the specific season. So I guess if I remember correctly, your conclusion was this upcoming fire season is going to be more severe than average.
Above average. I don't want to jump to say that it was extreme. Certainly I probably said last year was going to be extreme, and it was really just kind of above average.
Right, okay.
Mind you, we missed that one kind of cool weather in the prairies. If we'd gotten that, we might have had an extreme.
Yeah.
Anyway.
So sort of like regardless.
That's my excuse I'm sticking to.
So regardless of the late start and the potential early end of the season, it's still going to be an above average.
I believe so, yeah.
Okay.
Yeah.
So does that kind of indicate that the severity in the fire season months are above sort of a normal severe condition?
Well, that's more or less what these maps are showing.
Yeah.
This pink area is indicating that it's one standard deviation above average. I mean, it's one standard deviation away from the mean. So all the white areas are going to experience fire conditions within a standard deviation of what they normally experience.
Right.
Again, this varies geographically. But what we're seeing here, this pink area, is basically the 66th percentile or higher of fire weather conditions. Again, an important concept to remember is you still need, these are fire weather conditions, you still need that spark to actually set that fire. Likewise, this doesn't capture any of the suppression efforts. If there's a sufficient buildup that they see coming, a provincial agency would likely collect together all the resources to manage that situation. If the situation changes rapidly and they don't see it coming, they could be, knocked in the nose there, perhaps, or even an extreme weather event, much experienced like at Slave Lake or the Richardson Fire, where these extreme winds pushed a fire that under normal fire conditions shouldn't have gone that far. But because of these 100-kilometer-per-hour winds, boom, there was nothing you could do. It was explosive. These models don't pick up explosive situations. But anyway. So at this stage, do we have any further questions?
Kerry, I have a question.
Yes.
Your first couple slides, you talked about using the CMC input and that, but you also talked about input from agencies. This is slide 2 or 3 years. When you summarize...
Okay, at the very beginning of the talk, okay.
Yeah, sorry to take you back that far. I was just curious about, what is the input from agencies?
Okay, I talk about input from...
Back, where was it?
Maybe it was the introductory
further
slide.
on, I think he meant the other one.
Okay, well, let's stop here. This is a good point to maybe answer that question. What's driving a lot of what's behind the CWFIS is provincial data. The provinces are giving us all their observations from hundreds, 1,000 weather stations across Canada. Alberta has probably like about 150, 200 lookouts that are collecting noon weather conditions and calculating fire weather. they're passing that information on to us. That data is reflected in the fall conditions, so those drought code conditions is based on provincial data. Also, in the spring, I'm often talking with provincial agencies about their kind of assessments of what the fire season might look like. Sometimes I could probably do a better job than not, but certainly I've been talking to a few people. I've been talking to Saskatchewan and to Yukon, for example, getting their feedback. I've sent them this presentation and they've responded, and so we're kind of collaborating. And towards the end of the month, we're going to be putting together a North American seasonal assessment based on this work, as well as input from the provinces. So yeah, I try to incorporate them as much as possible, but they're also busy with ramping up for their fire season too. So often they're distracted and they don't respond as quickly as I'd like. That answer the question?
Yeah, that does. Yeah, no, for sure.
Okay.
Thought you were going off track there for a minute, but you can. As you always do, Kerry.
Oh, yeah.
Can I make one more comment just about the 2012 season? And you know, you can go to those maps if you like, but I think just in terms of the audience here, I think the 2012 season was relatively a sort of a normal season. I think one of the exceptions was Eastern Ontario, which had as dry conditions, you know, in terms of you know, duff moistures and drought codes as I've seen in years or decades, and fire activity down in the Ottawa Valley, like the ignitions down in that area. That there were really sort of exceptional dryness really from Huron on east, and in terms of potential impacts, I think it was one of the few places where there were New Liskeard with fires on the outskirts dropping embers into town. Timmins with a big fire threatening it for a while. All well managed fires and getting some breaks in the weather that didn't end up pushing extreme fire into town. But I think from thinking about the risk and exposure point of view, that was probably the area in Canada with the biggest sort of anomaly, or the biggest standout. I would think, and I may be forgetting something across the country, but that and again it just sort of coupled, there's the deep dryness, and I think there was smolder and deeper burning going on till late in the summer, but also this fire flap around in the northeast. I think it was a really interesting one, risk and exposure point of view.
That's a good point you bring up. Being from Alberta, from Edmonton, we're used to dealing with like a large fires, like 100,000 hectares, right? I'm used to big fires. On the other hand, maybe what was experienced in Eastern Canada, they didn't show up as large fires, they showed up as small fires, but probably well out of the norm of normal fire activity. Somewhat in defense of this forecast here, we actually did a comparison of the observed monthly severity rating, and with the exception of kind of this area in the southern prairies, these maps weren't really that bad. We did pick up a lot of these above average conditions. I regret that we did a poor job in deciding the boundary between the pink and the red. We were doing a lot of debating on it. We were trying to tie it in with data, and we were looking at Edmonton's weather, I believe, and setting it as kind of like the 90th percentile or something like that, or the second standard deviation. But anyway, we're getting into details. It was a poor choice for coloring, but it did show that a lot of this area did kind of match up with what was observed. And indeed, any of those that receive this PowerPoint will probably see my hidden slides where I actually show that. I thought I wouldn't get into that sidetrack, but you're welcome to kind of look at the original presentation and dig those hidden slides up. Anything else? Yes.
To a layperson, I think, like myself,
Yes.
you would always think that big wildfires tied to drought or dryness at least, not maybe not necessarily, but at least dryness. But then we have Slave Lake, and I think that was kind of I hate to use the term wake-up call because it's so overused these days, but it was a normal winter, a fairly normal spring in northern Edmonton. I heard that there was, in Alberta, I heard there was snow on the ground the week before Slave Lake.
About 3 days, I think it was, yeah.
And all you really need is a few days of low humidity and bang. And so I think, is there kind of this misperception that you need drought, you need dryness, you need prolonged hot weather for a big fire, or like should we really be thinking about the Slave Lakes again, and that you don't really need those conditions for a wild card fire like that?
Okay.
I mean, I don't even know what the question is to tell you.
Okay, no, fair enough. These are good questions. And Mike will probably wrestle with me after this meeting about what I say. But anyway, what I talked about with Slave Lake, and there are official reports on this. I'm probably not the authority to be talking on it. As I alluded to earlier, it was an extreme wind event that caused the fire escape and catastrophe that happened at Slave Lake. It was the same wind event that drove the Richardson fire that ultimately burnt 500,000 hectares and just missed the oil sands too, which is an interesting insurance topic. But anyway, you don't need drought to catch these extreme events. We're not going to be able to catch every extreme event. Hopefully the forecasters will see this coming, but and indeed in defense of people like Nick Dimchuk and Paul Kruger and Liz in Alberta, they did see this stuff coming. But even if you see this stuff coming, how can you deal with this? They couldn't land air tankers on Slave Lake because it was too choppy. The major run probably happened in a handful of hours. They were swamped. I mean, they pulled in every resource they could. These events will happen and possibly will continue to happen as we move into this climate change scenario that I was discussing earlier about how the weather conditions will likely fluctuate with extreme conditions. Whether it's a blow-up fire in Slave Lake or whether it's Snowmageddon in Washington or whatever. We're going to see more of that, I think. And, I think it's mainly through kind of preventative measures beforehand that hopefully we could kind of approach these and mitigate the impact of these. Protection of communities through fire smart plans and whatnot. Try to prevent these explosive situations from happening in the future. Yes.
Can you just ask a question about the political side of fire suppression up there? I think my interpretation is in the past we've seen good provincial activity and interest in suppressing fires in northern B.C. and in Alberta, but less so in Saskatchewan, I think. Is that what you've seen? Is that changing?
I'm probably not qualified to talk too much in detail about this, and also I'd probably be talking on thin ice if I did. But regardless, each province has different rules and regulations about how they manage fires, and indeed. If we take the case of Alberta versus Saskatchewan, Saskatchewan has what they call an observation zone in the northern half of the northern third of the province, where they let fires burn naturally unless they're threatening communities. In terms of the involvement of various provincial agencies, that's provincial jurisdiction, and these guys are setting their budgets. The legislatures are setting their budgets and deciding how much to spend on fire suppression. And that has a big impact on that too. I mean, we've got have provinces and have nots, and I'm not even gonna try to, it's not my place to say which is which. we'll continue to have these sorts of issues. I'm dancing around, not quite answering your question, am I?
Well, it just seems
it's just a fact of life in a sense.
I see, over the years, a tally of a lot more hectares being burned in northern Saskatchewan than we see in the other provinces, and I've kind of attributed that to political will.
Well, I wouldn't say political will as much as kind of reality. Alberta stands out a bit more uniquely in the sense that they don't have an official observation zone. But most of the other provinces have observation zones, whether it's northern Saskatchewan, Manitoba, the area kind of beyond Thompson, Manitoba is primarily kind of observation zone. Northern Ontario, northern Quebec. Most of the province, I mean, it's just a reality. If there's very few people living in these areas, there's less incentive. If there's fewer resources, fewer people, less incentive to put a lot of resources into this. This was an issue, I remember, I'm starting to sound like an old man talking here. I remember when. This was an issue in the Yukon, when a colleague was working up in the Yukon, where there were some people who were very active and they wanted to fight every time there was smoke on the landscape. Let's send out everything we got to put it out. But there were others that were recognizing the fact that this isn't having any impact on anyone. Let's let it burn naturally. Talking to communities, kind of, do you want us to fight this fire, or do you want a new community center? You can't have both, So suddenly you start to play this political game, and you end up with these areas that are high priority and low priority, and I hope I'm not getting into any trouble here saying stuff like this.
Yeah, I think what you see in the records there, I mean, that is not, I wouldn't frame it as political will, but simply an indication of the policy. And you'd see the same in chunks of northern Ontario, or, as Kerry says, northern Manitoba. And, it might be the political will of enforcing that policy, or the ecological benefit of that policy. But I mean, it's a conscious policy choice itself to let fire play whatever natural role it can there. As Kerry says, I mean, threatens the community.
I'll just ask one more question back to Slave Lake again.
Sure.
When we're looking at, I'm sure everybody's been over and over the results of the fire suppression activity and the way the wind blew and how what exactly happened. But after the lessons are learned and all the data is in, do they ever look at the infrastructure surrounding the whole town, in as much as for fire suppression activities, perhaps only one road in to the town was a little lacking, that sort of thing? Does anything like that come into play in any of these discussions, for getting right down to infrastructure and actively saying, well, how would we better be able to take care of a situation like this? That sort of thing. It's another soapbox thing I've been.
Okay, no, fair enough. And again, I should, I should maybe back up a little bit and say that, I repeat again, this is.
I know it's
not
scale.
Not quite my area of I'm not quite as qualified to answer this as other people, and when I start to say things, it might suddenly start appearing that I'm judging the quality of.
I don't need a specific.
But yes, this stuff
has been reviewed.
This is being reviewed, but to the extent I honestly can't say. There are people that are.
Report that has come out on the fire. And that touches on some of that, and also KPMG has been secured by the province to do some further investigation.
Yeah.
What website can you get the report?
It's fairly easy to find, but I'll see if I.
The province put out a report. I know that.
Yeah, Flat Top Complex report.
I know that.
Fire 65, I think it was. Fire 65.
One of our researchers was on that team there investigating it. I don't get me wrong. This is taken very seriously, obviously, and reports are put together. I mean, Kelowna is another example. The the premier, what was his name again?
Philman?
Philman.
Yeah, the
report,
firestorm.
into that. How much of these recommendations get followed up on? It's hard for me to say, and it's probably, if I did say something, I could get into trouble. But this stuff obviously is taken very seriously.
Okay.
Anything else? Now, how are we doing for time?
Got some time still, it's 11.
Okay, I'm still okay. Maybe people might want to check out, I don't know, but we're going to go into a slight, we're going to take a bit of a turn here. And I wanted to discuss very quickly a colleague's model here. Okay, and just to recap, why I'm doing this is because I've got an audience here that may be interested in this sort of work. Since my last year's presentation, I've actually been approached by a couple or three insurance companies with various requests, okay? And it's put us in kind of an interesting situation. As a research establishment, many of our scientists are more interested in developing models and getting publications, but are less kind of, we're kind of caught in an awkward situation when we're asked, can you do this work for us? Because we're not really quite a contracting firm or anything like that. There are consultants that do this stuff, but as a result of those sorts of requests, we kind of put our head together to try to kind of come up with some sort of a strategy. What exactly would insurance companies such as, you know, the people I'm talking to here, could take advantage of? So rather than have all sorts of people wandering off into various random directions, which may or may not necessarily be the best methodology, I thought we'd kind of present quickly one possible approach. And this is a model called Burn P3, developed by Mark Perezian in Edmonton. Burn P3 standing for, what is Burn P3? Well, it's P3, what is it? Probability and, I don't know, there's 3 P's in there somewhere. But it's a landscape model, okay, that simulates both ignition and spread. You may recall in my seasonal forecast there I talked about you can have high fire danger, but you still need that spark. You still need that match falling on the ground to set that forest fire. It's designed to look more to long term. Currently they're using it in fire management to try to figure out which areas are more prone to fire than others. Also, it's a Windows software program, so anybody could download this and with a bit of effort can be quite proficient at this. Essentially, the idea is to take into account ignitions, fuels, that's a fire kind of term for trees, and topography. I mean, obviously fires like to burn up slope faster than downslope. We also look at long-term weather conditions, durations of drought, daily conditions, and we combine that and feed that into a model called Prometheus. This is a fire growth model. And by doing multiple simulations of Prometheus, simulating kind of hypothetical fires, dropping thousands upon thousands of fires on the landscape, we start to see patterns of where fires may occur and which areas are more under threat. And so you can imagine here, it's shown here in this red square, we calculate through all these various fire perimeters shown by these ellipses, we can calculate how often that cell gets burnt. And in this case, it might have burnt, you get a 1% or 0.1% chance of that burning in a year. So this little cool little simulation shows how over many years of dropping forest fires on the landscape, areas tend to burn possibly multiple times. we end up seeing a pattern that ultimately takes hold. And we can start to see that some areas are more prone to fire than others. And this takes into account all the factors such as the topography, the types of trees, the weather at that location. All this information's fed in and developed through this probability model. It's a Windows package, so it's something that one could download and develop some basic skills. There's a manual on this, so it's well documented. It's being used by a number of different agencies, provincial agencies. There's consultants that are using this. Ultimately, it's a fairly easy program to use. This is an example of a publication where Jen Beverly, a former research scientist of ours, used Burn P3 in the Whitecourt Swan Hills region to predict which areas were more prone to fire. Likewise, Mark is currently doing work with the national parks here in Revelstoke in this case, where they're taking into account the topography. There's the fire history showing where the fires have occurred in the past. Combine that with the types of trees. There's the elevation again. Put all this together and you end up with these probability maps showing where fires are more likely to occur than others. And perhaps doing this sort of stuff, you can kind of get a feel for which communities may be under threat.
What's the time scale, like probability of fire within blank?
Well, it's a good question. I think it's basically it's annually. That's my understanding. This program runs thousands, if not tens of thousands of fires, but each fire is kind of dropped on the landscape independently, so there's no real time step per se. But I believe it's kind of the value is sort of annual. Here we're looking at the fire intensity. Which areas are more prone to the most intense forest fires? Yes.
Just a quick question. All these elements together, when do you decide that a fire ignites and where? How does it decide? So it takes in all of this data. At what point does it decide that? So it simulates these fires over and over and over. But when and where does it decide that?
It's based on historical patterns.
Okay.
So we see which areas are where fires have occurred in the past. So you see where the fires have occurred in the past. You pull that information out. You apply some kind of a smoothing algorithm to start to fill in some of the gaps, because that's probably 30-year or 40-year fire history there. But ultimately, you're let's see if I come back to your question again. Yeah, you're taking this fire history and using that as a probability map to randomly drop fires on the landscape. If you're talking about like when's the next fire going to occur and where, well, that doesn't quite answer that question. You need to move into another branch of fire science called fire occurrence prediction, and that's kind of in development.
It's kind of like an if model as opposed to a when model. So if a fire were to start here, this is what may happen.
That would be a fair way to say it. Well, it's a probability model. It's saying which areas are more prone to fires as opposed to others.
Fire hazard, kind of like a flood hazard map. So you don't know when a flood will occur in the 100-year flood.
Yeah.
You know it's more likely in that area than in other areas.
That's a good analogy. Yes. Yes.
So you say that anyone can download this, and with a bit of effort they can use it.
Yeah.
The inputs are fuel, topography, and weather.
And weather, yes.
Are data sets for these inputs available, or is this a sort of tool where you download the program but you have to have all your own data on these three subjects?
Well, you would have to collect that data. That's where your kind of expertise would have to kind of start to kick in.
Mhm.
Also, this is maybe perhaps, I don't want to sound like I'm encouraging it, but this is the realm that consultants like to do. And if you wanted to kind of go down that direction. I don't want to come across as promoting kind of consultants over fire, like this is sort of work that we're interested in, that we have done in the past, but our scientists tend to want to kind of focus more on getting publications out of their work because that's how we advance our careers. But certainly, you could talk to us if there's a certain amount of interest generated, that's something that we could pursue. I was talking in the room earlier today about maybe it would be interesting if we could do a whole map of Canada at a course scale, doing this sort of approach. Of course, I'm promising, it's not me to make this promise, it's Mark Parizien to make that promise. But this is an example of what we could do. But this would be a practical tool for insurance companies. So that's why I'm making you guys aware of this. And the quality of the work depends upon how much work you want to put into it. So if this is something that you're interested in, you want to follow up on, please contact myself or Mark Parizien. If you do a Google search on burn space P3, you might find some information on it, but I could always provide you with that later. And I believe that's about it. There might be a kind of a concluding remarks. Simulating ignition encounters a spatial context. Okay, as you alluded to, it's a very data-hungry model. It incorporates natural variability. Interesting patterns develop, like actually the area around lakes tends to be less prone to fire than the countryside because of these shadows that the lakes will create. Fires will move around lakes. And it's easy to do a lot of what-if scenarios where kind of if we started building fire guards here, there, and everywhere, what happens? And that's the end of that talk. So again, feel free to contact me if there's any information you want to follow up on this talk or the seasonal forecast. And I think that's about it, unless there's any more questions from the table.